Hello students, so we are discussing PID controllers, their various types. Okay, so we are studying types of controllers. So last time we have seen there are 4 types of controllers: proportional, that is P, proportional derivative PD, proportional integral control PI, proportional integral derivative controller, that is PID. So these are the 4 types of controllers. So last time we have seen proportional controller. So here, just for the sake of revision, we are repeating proportional controller. In proportional controller, the output is directly proportional to the error signal. So if the error signal is voltage and the control signal is also voltage, then a proportional controller is just an amplifier. So in the figure you can see the construction of proportional controller. So control signal equal to Kp multiplied by error signal. Then under properties we have seen steady state error tends to depend inversely upon the proportional gain. So if the gain has made larger, the error goes down. Now this type of controller helps in reducing the steady state error, so it makes system more stable. Then under shortcomings, P controller has the advantage of reducing down the steady state error of the system, but along with that it also has some serious disadvantages. So under disadvantages of P controller, we have seen first one is due to presence of these controllers we some offset in system. Then proportional controllers increases the maximum overshoot of the system. Then it directly amplifies process noise, so that is not desirable. Actually it should not amplify process noise. Hence, to avoid these errors and to make the controller more accurate and practical, we use the advanced and modified version of it which is known as proportional integral controller, that is PI, and proportional derivative controllers PD, which are going to see in our next slides. So now proportional derivative controller, that is PD controller. So this kind of action gives an output which is proportional to the derivative or the rate of change of the error. And derivative action could not be used alone in practice. This is because its output is only related to the rate of change of the error. The error could be huge, but if it were unchanging, the controller would not give any output. Thus, although it is theoretically possible, it is practically impossible. Now, derivative controller control is usually found in combination with proportional control to form so-called P plus D. So in the figure you can see PD controller. Now properties and advantages of PD controller. Here output derivative controller's output is given as OD equal to minus KD DER divided by DT, where OD is output derivative controller, then KD derivative gain or action factor of the controller, then DER derivation change over the time sample, DT is time sample, then derivative part in the PD controller reduces the overshoot and improves the transient stability of the control system. It reduces the time constant of the system and thus making system more faster. It has no effect on the steady state error derivative part and on the offset caused by the P controller. Now the third controller is proportional integral, that is PI controller. As the name suggests, it is integral controller. The output, which is also called as the actuating signal, is directly proportional to the integral of the error signal. Integral controllers used alongside with proportional controllers are called as PI controllers. So in the figure you can see so the controller equation also you can see in the figure. So just like PD controller, it is has a parallel connection of P and I controllers. Then properties, advantages of PI controller. Output is proportional to the integral of the input signal. Then as the integrator is involved, it increases the type of the system. As the type of the system increases, it reduces SSE and hence improves accuracy. Then integral action enables PI controllers to eliminate offset, a major weakness of a P only controller. Thus PI controllers provide a balance of complexity and capability that makes them by far the most widely used algorithm in process control applications. As the type of the system is increased, there is some negative impact over the stability of the system. And the last type, that is proportional integral derivative controller, that is PID controller. Now PID controller involves all the three controllers studied earlier, that is P, PD and PI connected in parallel. So you can see in the figure. So here the three types of controller are connected in parallel. The PID controller involves the parallel combination of these three controllers, and the output equation is proportional to the derivative as well as integral of the error signal. So in the figure you can see for proportional, then for integral, and then for derivative the equation can be given in this way. Then the characteristics of P, I and D controllers. A proportional controller KP will have the effect of reducing the rise time and will reduce but never eliminate the steady state error. And integral control will have the effect of eliminating the steady state error, but it may make the transient response worst. And in case of derivative control, that is KD, will have the effect of increasing the stability of the system, reducing the overshoot and improving the transient response. Now all design specifications can be reached within the PI controller and 100% desired condition can be achieved. Now in the figure you can see the effect of increasing the individual gains. Now in the figure you can see for proportional, integral and derivative control systems or control symbol response here in this figure: rise time, overshoot, setting time, and assess error. So just have a look at the table here, which will compare all the three types of controllers. And now, tips for designing a PID controller. Here, obtain an open loop response and determine what needs to be improved. Then add a proportional control to improve the rise time. Then next is add a derivative control to improve the overshoot. Then add a integral control to eliminate the steady state error. And finally, adjust each of the Kp, Ki and Kd until you obtain a desired overall response. So these are some tips for designing a PID controller. So friends, we have seen four types of controllers, that is proportional controller, that is P, then proportional derivative controller, that is PD, next then proportional integral control, that is PI, and finally proportional integral derivative controller, that is PID. Okay, thank you friends. Thank you.